Let's start talking now about Lindsay's second baseball paper titled The Progress of the Score During a Baseball Game, published in 1961. And the first question of the paper deals with the homogeneity of run scoring for any half inning. Is the probability of scoring in any half inning the same? In other words, are there any differences across the various innings? The second question related to this is, does the history of scoring affect any subsequent innings? Is there any hysteresis effect? Is there any carryover effect? Or can you consider every half inning as an independent event? So the alternative theories, the alternative ideas to these questions of homogeneity and independence are that pitchers may get tired and pitchers may lose their dominance. You may change your tactics as a manager as the game goes on. And by changing tactics, you change the homogeneity of run scoring in innings and the independence of run scoring throughout the game. In other words, maybe in the ninth inning tactics change, thereby changing the amount of runs scored in that inning or creating a discontinuity in the independence of run scoring by inning. So this was the kind of question that Lindsay was after. And again, by very close observation of run scoring in various half innings, he collected data like this. So this is from his paper in 61, and this is looking at 782 games from 1958. And what they're showing here is the number of runs scored in the inning. That's across the board here. Okay, the number of runs scored is either 0, 1, 2, 3, 4, 5, or more than 5. And this is every inning: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then extra innings. And then he combines all innings and all extra innings to get it averages. So just look at the first inning. 71% of the time, 0.079, is how often 0 runs are scored in the first inning. 1 run is scored about 15% of the time. 9% of the time you get 2 runs, and all the way down this row. For that situation of run scoring in the first inning, he had 1,564 observations. And he had 1,564 observations until he gets to the 6th inning, and this is because of incomplete games, because of games being called due to weather. And once you get to extra innings, the number drops off. And this number drops here in the 9th inning because he doesn't include all partial innings. He only includes complete half innings that he sees. This column here is the mean. These are the averages. So the first inning, on average, you're going to score 0.53 runs. Second inning, 0.38. Third inning, 0.53, all the way down the line. This is the standard deviation column, and this is the standard error column. So these are the data he collects from 1958. In 1959, very similar setup. Every inning, he starts looking at the run scoring probabilities. There's 0 runs scored 70% of the time. 16% of the time it's 1 run, all the way down. And the mean for the first inning is 0.54 runs scored. Again, standard deviation, standard error. And he has 2,000 observations. Based on 1,000 games, he has 2 half innings for every 1,000 games in 1959. So he's got 2 data sets, and he collects them differently here. 9th inning data set, he has complete and incomplete innings, extra innings, complete and incomplete innings. So he separates this out and counts them differently. From before, he only counted the complete innings. In the previous data set, all he had was the complete innings, if you go back to 1958 data set. So these are the data he collects. And right away, you can see that it's not equal. Okay, now a lot of them look the same in the ballpark, but the second inning looks like something's much lower relative to the rest of the run scoring. If you look at the 1958 data, we'll go back. Same idea. The second inning has a little bit lower run scoring average than the first inning or the third inning. And the other data looks relatively similar. The first question he's trying to answer, again, is the idea of inning homogeneity. Is the probability of scoring a run in any half inning the same? Well, it doesn't look the same. It looks like there is a difference. He shows this graph here, and the previous tables are now graphed above this line. First inning, the black is 1958, the white bar is 1959. And what's represented here is the mean plus or minus the standard error. And you can see the dotted line here is the overall mean of run scoring per inning. And you can see how first inning's a little high, second inning's a little lower than the mean, third inning is a little higher than the mean, and then the rest of the data looks like it's closer to the mean. The 10th inning has big spread, extra innings have a big spread. The standard errors are much larger. There's lower counts. That sort of makes sense. That's the data that's starting to be scored. That's the data collected by Lindsay. Now, the bottom half of this graph just looks at probability of bigger innings, the probability of scoring more than 3 runs in an inning. So this is a bigger inning than most. The third inning looks like the big inning. That's the probability of scoring much more runs. It looks like that's much higher. 0.065 or so, 1 out of 16 innings or so. 6% of the time is when you would score a big inning in the third inning. So this is the big inning trend over time. And the probabilities look different again in the second inning and the third inning. They look different here. And this is probably due to lineup construction, and this is what Lindsay talks about. He looks at the data and he does statistical analyses on the data to show that the first, the second, and the third inning are different than the mean, are different than the overall average. So what he concludes is this: run scoring is not homogeneous. It is not the same across all innings. The first 3 innings are different from the mean. First and third are higher, the second is lower. So there is no run scoring homogeneity by inning. And what he says is this is a quote from the paper: "It seems logical to attribute the inhomogeneity of the first 3 innings to the structure of the batting order." In other words, the managers have set up the batting order to score runs at the top of the order and maybe not worry about it as much at the bottom of the order with weaker hitters. So the structure of the batting order is a direct effect here.